Hello. Hi everyone. Welcome to our week 8 C++ programming. I am Emmanuel, sorry, and today we are going to explore an advanced but essential concept that will make you a better C++ programmer. Today we're talking about namespace and exceptions. Namespace and exceptions. Let's have a look at our learning objectives for today. So this week we will learn about namespace in C++, understand the compilation and program structure. You understand using of header files. You will learn about exceptions also. What is namespace? How do you understand what namespace in programming, C++ programming? Talk about namespace. Just think of namespace like organizing files in different folders on your computer. Just like you might have photos folder and documents folder to keep things organized. Namespace helps us organize our code by grouping related items together. So a namespace is a feature that provides a way to group related identifiers. Related identifiers such as variables, functions, and classes under a single name. That's the namespace. We talk about namespace, that's the namespace. It provides a space where we can define or declare identifiers. In essence, namespace defines a scope. Namespace defines a scope. This is the definition on the slides. The namespace defines a scope. But why do we need this? Just imagine you are working on a large project with multiple programmers. Two programmers might create functions with the same name like print. Create the same name like print. Without namespace, the compiler would get confused. Namespace solves this problem by creating separate containers for the functions. That's what we term as namespace. That's the work of the namespace. Namespace definition. Now let's move on to namespace definition. What's the namespace definition? It begins with the keyword namespace, then it's followed by the namespace name. So creating a namespace is just straightforward. You begin with the keyword namespace, you follow it by the namespace name. That's the basic structure. Let's have a look at the structure. This is the look of the structure. Think of like creating a labeled box called programming and putting your function inside it. That's the namespace definition. There's such a code for namespace definition. Now let's continue with how to access the namespace members. Accessing namespace members. How do you access them? Once you have created a namespace, how do you see or how do you use what's inside it? You need to tell the compiler exactly which box you are looking in. So we access these members using the scope resolution operator. As you can see here, the scope resolution operator, which is the double column. Two columns, which is the two columns, double two columns. Let's have a look at the structure here. The namespace name, then the member name. You bring your two columns here, then you access it. Let's have a code example here. Accessing namespace members. This is the code. Sometimes typing namespace name every time can be tedious, so we use the using directive method, and that's like saying I am going to be using items from this specific box a lot. So just assume I mean this box unless I say otherwise. That's how we use the namespace using directive. So the using directive tells the compiler that the subsequent code is making use of names in the specified namespace. This directive tells the compiler that the subsequent code is making use of the names in the specified namespace. That's the using directives. That's the using a directive here. Now let's continue. This is a structure, error code structure here. This is exactly what we do when we write using the namespace std at the top of our programs. That's how everything goes. We also have the types of namespaces. We have the types of namespaces. You have the built-in namespace. You have the inline namespace. We also have the anonymous namespace, the global namespace. And let's explore each of them in details. For the inbuilt namespace, these are the examples. You have the types of namespace. You have the inbuilt namespace, inline namespace, anonymous namespace, and global namespace. Let's dive in one by one. When we talk about the inbuilt namespace, they are like pre-installed apps on your phone. They come with C++ and contain useful functions and objects that you can use right away. That's the inbuilt namespace. They are part of the C++ library, which contains most of the built-in functions, objects, and classes. They also avoid conflict between user-defined and library-defined functions or variables. So the most common built-in namespace is the std, which is a standard. Then we have the std namespace contains most of the standard functions, objects, and classes like cin, cout, vector, string. We also have the sender. So this is std namespace, a namespace that is part of the standard library. It contains the class, functions, objects, and classes like cin, cout, vector. So let's see this inbuilt namespace. This is the code for it. Inbuilt namespace. Without using the namespace std directive, you need to explicitly specify std before standard library functions for each code. Let's continue to inline namespace. We talk about inline namespace. An inline namespace is like having a box within a box, but the inner box is so convenient that you can access its content directly without opening it first. That's the inline namespace. It's where its members are accessible directly without using the namespace name. Its members are accessible directly using the keyword inline. Let's have a look at the structure, the code here. Inline namespace, the code. So I have this here, direct access due to inline namespace. And let's continue to anonymous namespace. When talk about anonymous namespace is like having a private room in your house. Only people in that specific house can access what's inside. So anonymous namespace does not have a name called an anonymous namespace. It ensures that the entities in the unnamed namespace are limited to that file. That's what we call anonymous namespace. Let's have a look at the code. Anonymous namespace. As we continue to exception handling, anonymous namespace here. Now, exception handling. What do you mean by exception handling? Exception handling is based on keeping the normal functionality of the program separate from error handling. Imagine you are cooking and something goes wrong. Maybe the stove stops working or you run out of ingredients. Instead of you stopping and leaving everything a mess, you have a backup plan. That's exception handling. Exception handling in programming works similarly. Exception handling is based on keeping the normal functionality of the program separate from an error handling. The basic idea is that errors occurring in one particular part of the program are reported to another part of the program, known as the calling environment. Which performs central error handling. That's the calling environment. So the part of a program that performs central error handling is referred to as an exception handler. So the calling environment performs central error handling. and the part of the program that performs central error handling in the calling environment is referred to as an exception handler. Know the difference. Exception handler. Let's move on to the component of exception handling. There are two main parts for implementing exception handling. So the component, we have the first part, we have the part of the program that can throw exceptions. This is where the problems might occur. And the point two, you have the exception handlers that will process the various exception types. And this is your backup plan. Think of it like having a fire alarm system, the smoke detector, which is the part one, detects the problem and alert the fire department, which is the part two, who knows how to handle the situation. That's the component. Let's move on to try and catch blocks. What do you mean by try and catch blocks? C++ provides an inbuilt feature for handling exception using the try and catch block. It's an exception handling mechanism where the code that may cause an exception is placed inside the try block and the code that handles the exception is placed inside the catch block. So C++ handling exception using the try and catch blocks. The try block contains code that might cause an exception. It's like saying try to do this, but be prepared for problems. And the catch block contains code that handles the exception. That's your backup plan when things go wrong. So let's have a look at the basic structure. This is the syntax. Continue with throwing exceptions. What are throwing exceptions? Throwing exceptions means returning some kind of value that represents the exception from the try block. It's like raising your hand to say stop, there is a problem here. That's throwing exception. Throwing exception means returning some kind of value, the exception from the try block. The matching catch block is found using the type of the thrown value. So the throw keyword is used to throw the exception. Let's have a look at the syntax. Well, there are three types of values that can be thrown as an exception. Three types of values that can be thrown out as exception. We have the built-in types, which is like the integer, then the character. We have the standard exceptions, the predefined exception classes. We have the custom exceptions, which is your own exception classes. Now let's move on to throwing standard exceptions. But before that, let's have a look at the built-in types code. This is the structure of the built-in type codes. Structure of it. Then you continue with the next one. So I have this one here. You can pause the video and try it yourself. Now, throwing standard exception. Throwing standard exception. Standard exceptions are the set of classes that represent different types of common exceptions. They are like having a professional emergency response team. They are predefined classes that represent different types of common exceptions. So all these classes are defined inside the std except, which is highlighted here, inside the std except function or header file, std except header file, and are mainly derived from the std exception. Derived from the std exception, so it's highlighted here. Classes which act as the base class for the inbuilt function. Someone will be like, what are the benefits? What at all are we using exception handling for? And let's have a look at this. The benefits of exception handling. The benefits of exception handling. Exception handling provides several important benefits. And we have the first point as we have the separation of error handling code from normal code. But before that, let's have a look at the standard exception, the code, and the structure for it. We have this here. Okay, separation of error handling code from normal code. The first point of the benefit of exception handling is your main logic stays clean and readable, while error handling is organized separately. Now the second point, we have the functions or methods can handle only the exception chosen, and as you can choose with exceptions to handle enrich, to let, propagate, up to calling functions. That the functions or methods can handle only the exception chosen. And the last point, we have the grouping of error types. When you talk about grouping of error types, you mean you can handle similar types of errors together, making your code more organized and maintainable. Exception handling makes your programs more robust and professional. Move on to separate compilation. Separate compilation. It's a function definition. A function definition is a function declaration in which the body of the function is presented. So now let's talk about how C++ programs are structured and compiled. Think of building a house. Instead of building everything at once, you might build a foundation first, then the walls, then the roof. Each part can be built separately and then combined. This is similar to how C++ handles separate compilation. In C++, you can write different parts of your program in separate files and compile them individually. Then later, these compiled pieces are linked together to create the final executable program. So this approach has several advantages. That's faster compilation, you have better code organization, easier teamwork, and code reusability. Let's have a structure. Let's have a look at the structure here. So a function definition includes a return type, a name, a parameter list, which is optional, and a body enclosed in a curly braces. This is editor, compiler, library, linker, loader, execution. Let's talk about header files. What are header files? C++ offers ACE uses a variety of functions, one of which is included in header files. In the C++, all the header files may or may not end with the .h. Header files are like instruction manuals or blueprints. They contain declarations that tell the compiler what functions, classes, and variables are available, but not how they are implemented. Think of a header file like a restaurant menu. It tells you what dishes are available and their names, but it doesn't tell you the recipe for making them. So header files, you have some components of the header files. In this component, you have the function definition as the first component. We have the data type definition as the second component. We have the macros as the third component. The function definition is what functions are available. The data type definition, what some data types you have created. Then the macros are preprocessor definitions. Let's have a look at the syntax of the header file. Now, ways to include the header files or importing header files. There are two ways to include the header file. One, we have for system or standard library files, and two, we have for user-defined files in the same directory. That's the ways to include header files. Ways to include the header files. We have the system or standard library files. We also have the user-defined files in the same directory. Now let's move to importing header files. How do we import header files? We import header files into our program using the preprocessor directive #include. The #include. The preprocessor directives are instructions to the compiler that these files need to be processed before compilation. It's like telling the compiler, before you start compiling my program, please read this instruction manual first. So these preprocessor directives are used to instruct the compiler that these files need to be processed before compilation. Literally, the preprocessor copies the content of the header file into your source file at the point where the #include directive appears. Types of the header files. What are some types of the header files? There are two types of header files in the C++. We have the standard header files, which are the pre-existing header files. and we also have the user-defined header files. So let's explain this one by one. Let's take the standard library files. These are the files that are already available in the C++ compiler that we just need to import them. Standard header files are like tools that come with your C++ compiler. They're already there and ready to use. You just need to include them in your program. So the common examples are the IOStream, the CMAT, the string, the algorithm, and the Sino. You have the vector also. And let's move on to the user-defined header files. User-defined header files. These files are defined by the user and can be imported using the hashtag include. User-defined header files are like creating your own toolbox. These files are defined by you and can be imported using the hashtag include, then file name.h. So these are mainly used to encapsulate our own functions, classes, or declarations so that we can organize our code and reuse our code by separating it in different files. So they are mainly used to organize your code better. Writing user-defined header files. How do you write user-defined header files? To create a user-defined header file, first you write your C++ declaration and save it .h extension. Second, you include it in your main program using the hashtag include.h. Hashtag include.h, as you can see here. Now, when writing your header file, what are the things that you should not put in the header file? First, a header file should not contain ordinary function definitions, like put this in .c++ files. It should not contain ordinary function definitions. It should not contain data definition, for example, int a. It should not contain aggregate definitions. It should also not contain unnamed namespace. It should also not contain using directives, example, using the namespace foo, which is foo. Let's continue with program structure. What are program structure? So, talk about programs. What's a program? A program is a collection of separately compiled units combined by a linker. Every function, object, type used in this collection must have a unique definition. So, a program must contain exactly one function called the main. C++ program HPs can be created separately and then they will put together to form the complete picture. So most importantly, a program must contain exactly one function called a main, and this is where your program starts executing. So let's have a look at the program components. The main computation performed by our program starts with the invocation of the global function, which is the main, and ends with return from the main. The return type of main is int, and there are two standard forms. We have the simple form and we have the with command line argument. Have a look at the syntax. Have the int main here. Program component have the simple form and with the command line argument. We look at the program termination. A program can terminate in several ways. That's by returning from main, by calling the exit, by calling the abort, by throwing an uncaught exception, and by evaluating no except. So first point is by returning from the main, the second point by calling exit, the third point by calling abort, the fourth point by throwing an uncaught exception, the fifth point by evaluating no except. So by returning from main, that's normal and a clean termination. By calling the exit is immediate termination with cleanup. by calling by the abort, which the third point is immediate termination without a cleanup, and the fourth point by throwing in an uncaught exception, we have the abnormal termination. And by evaluating the no except, we have when exception specification is evaluated. By calling quick exits, we have the fast termination with minimal clean up. The most common and recommended way is returning from the main. So this brings us to the end of our lesson for the week 8. We deal with the tasks, the assignment here. Week 8 assignment. We write your given assignment on our previous lessons for the students' results display to include use of the functions and exceptions. Leverage your namespace for some tasks. So once again, I am Emmanuel, sorry, your lecturer for C++ programming.